Okay, it's time to solve some of these linear programs in R. And so here we go. We've got RStudio open. Here I've got downloaded and have the R Markdown file, week one, number two, solving linear programs in R. And here it is. So I'll give you a little tour as we're starting off this first one. So this is the setup of R Markdown. Code goes in these code chunks. That they start off with triple backticks and end with triple backticks. And then they have a little bit of a header stuff there. Most of it you don't need to worry about. This first code chunk loads the libraries that we're going to be using. If you have a yellow ribbon right across here saying that there's libraries that you need to install, go ahead and hit install and let them run through that. Pause the video and wait for that to finish. It should take a minute or two to install all the libraries that we'll be using today. So the code is here. Outside the code with the white background is text. It allows me to essentially document the code where I can have text and code right next to each other. And really the PDF version that is also linked with the handout is generated from this file. And so I'm able to generate PDFs of the notes with the code and in combination. But here we're opening the R Markdown file and we're mostly going to be interacting with the code. So here's the description of the Geppetto's workshop problem again. I'll let you sort of read through it as well. Here we can see it sort of written out in mathematical notation. In here with the double dollar signs, this is LaTeX, which is a fancy kind of math code to make pretty math equations. And so here are those, here's the linear program for the Geppetto's problem. Remember, we want to maximize the profit, which is 3 times the soldiers plus 2 times the number of toy trains made, such that, and then here are the 3 constraints. Soldiers plus trains has to be less than or equal to 80 to satisfy our limited carpentry labor supply. 2 hours per soldier and 1 hour per train has to give us a total hours on finishing less than 100. And then the limit, oh, actually I see that I got a typo here. It should be 1 for soldiers and 0 for trains. And that there's a limited demand for soldiers, that soldiers needs to be less than or equal to 40. So good, I caught that typo. It'll be fixed by the time you get the version of the handout. So now let's go about solving it. We're going to solve the problem using an R library called OMPR. This is actually a new library for me. I've in the past used LPSolve. This one's a lot more human readable, and hopefully that will be easier for you to pick up. It also interfaces with a bunch of pretty powerful back ends for different solvers. So that makes it kind of nice. So to start off, we're going to create a MIP model. This is a mixed integer programming model. Right now, we're going to mostly focus on the linear part, but these models can also handle integer and binary variables. And so we can go ahead and we're creating that model, and in R, this little assignment arrow assigns whatever we created to a variable named Geppetto underscore model. And so if I run that, and then I look over here in my environment, I've now got something named Geppetto model, and it's pretty much empty, but it's got everything that we need, or at least has our empty model. And if I type in the name of that model and run this line of code, it will show me at least a summary of what's in that model. And right now it has no variables, neither continuous, integer, or binary variables, no objective function, and no constraints. So it really is an empty model. So let me talk about how you can run the code. So maybe actually run this code first. Is a couple ways you can run code in RStudio. You can hover over the play button in the corner of a code chunk and hit play. and that will run the code chunk. You can also have your cursor in a code chunk and hold down Control-Shift-Enter. Will run the whole code chunk. Or if you want to run a single line of code, you can just use Control-Enter. So Control-Shift-Enter, whole chunk, Control-Enter, one line of code. And similar on Macs, it's Command instead of Control, but same or similar shortcuts. So that created the empty model. Now we want to add variables to the model, and we're going to make use of a R construct called a pipe. I really like pipes. They make code much more readable, but we're going to take our old model, or the model that's empty right now. This is the pipe. It passes it into a function called add variables. And so really you can think of this pipe as taking the Geppetto model and it places it inside of here. It makes it easier rather than wrapping functions inside of functions and sort of having a nesting Russian doll set of functions composed inside of each other. This pipe sort of unwraps the function composition and makes it easy to say that this is then passed into the add variables. And so here we're going to add a soldiers variable. The type is going to be a continuous variable with a lower bound of 0. We're then going to pass the result of that into another add variables command. And now we're going to add a trains variable, also with type continuous and lower bound 0. So the lower bound 0 enforces the non-negativity, and we're going to choose that these variables are going to be continuous variables as opposed to integer or binary variables, which means that soldiers and trains can take on fractional values. Even though in our scenario, we'd probably prefer integer variables instead. Practically speaking, continuous variables are much quicker to solve. Not that this problem will take very long for the computer to solve it. So, but just so we get used to continuous variables, that's what we're going to start off with. Though we'll introduce integer variables already by the end of today. So after we have the variables, now we're ready to add an objective function. So really, we are essentially going step by step through the same steps as we did when we formulated the problem. Now we're just translating our formulation into code that the computer can understand and read. So we can take our Geppetto model and we're going to pass it into a set objective function. And we're going to set the objective to 3 times soldiers plus 2 times trains. Now our objective function needs to use variables that we already defined using the add variables function up above. And so these variables here, soldiers and trains, need to match the variables that we created in the add variables command. And then sense allows us to set whether we want to do a maximization problem or a minimization. Do we want to maximize this quantity or minimize this quantity? And if we remember the setup, this is, we're talking about profit, and we want to maximize the profit that Geppetto gets by making his soldiers and trains. So go ahead and run this. Oops, I don't think I actually ran this. So run that, then run this, and it will be just fine. Notice I got an error when I forgot to run the add variables commands, because then it said it didn't know about soldiers, which was the variable that I'm using in the set objective. So once I've got my objective, so variable, decision variables, objective, now I'm ready to move on to the constraints. I've got 3 constraints. The first one is that soldiers plus trains has to be less than or equal to 80. Here, I'll comment this one. That is the carpentry constraint. And then we've got our finishing constraint that 2 times the number of soldiers plus 1 times the number of trains has to be less than or equal to 100. And then here is our demand for soldiers constraint. And that no matter how many soldiers we make, we can only sell 40. And so it's not worth making any more than 40 soldiers, because that's as many as we can sell. And so we're adding each of these constraints, and then we're assigning it back into the same model. And so instead of creating a whole bunch of models at every step, We're just overwriting Geppetto_model each time we're updating it. So once we've got decision variables, objective, and constraints, we're ready to solve the model. So those are the three things we need each time we create a linear program. We need decision variables, we need objective, and we need constraints. And once we've created those three and we've made sure we've gotten all the constraints, then we're ready to solve the model. And so we take the model, we pass it into the solve model command, and this with ROI solver GLPK is just a setting where we can choose what solver we're using to solve the linear program. I'm not going to get into too much detail. Certain solvers work better for certain types of problems. GLPK is a pretty good general purpose linear program solver. So not going to worry too much about which solvers. If you really are running a code a whole bunch of times, then you might want to profile the different solvers that are out there and see which are performing better on your types of problems. Some work better on smaller problems, some on medium, and some on large problems. So you can try each of those. So yeah, go ahead and run that. We will then store the result in a variable that I'm calling Geppetto result. Stores all the results of the solver. Okay, so we solved it, but where's the solution? Well, we stored it in Geppetto result. Let's look at some of the things inside of Geppetto result. First off, solution. If we, and this is a special thing about R, if we take a object and give it a $sign, then we can access the items inside of that object. And so in this case, the Geppetto result, here, let me actually delete the solution and put this $sign in. If I type in the name of the object and type in $sign, it will show all the things that are available there. Model, objective value, status. Let's actually look at status. Success. Yes, it means that we got to the solution and the solution was a success. There's also column and row duals, which have to do with sensitivity, but we won't worry too much about that. Let's do the solution again, and we see that our solution was 20 soldiers and 60 trains. That matches up when we with what we got when we solved this via the graphical method. How much profit should Geppetto expect to make it using by making 20 soldiers and 60 trains? We've got the objective value function that we can pass our result to, and that will give us our objective value of 180. So you should make $180 in profit by selling 20 soldiers and 60 trains. Okay, here are all those things that are stored inside Geppetto result, the output of the solve model command. You can get back the model. So really, I guess we didn't have to make the results a separate object. We could have just overwrote the model, and now it would be the model along with the solution. We can get back the model. We can get the objective value. We can get the status, the solution, solution column duals, and solution row duals, which those are both used in sensitivity analysis. And so we'll talk about that when we get to it. It's always nice to put things in a nice table. Here's cbind is column bind, adds things as columns, and I'll just show you what the result looks like. So we've got our solution here, and our profit is 180 with 20 soldiers and 20 trains. Here we're setting the column names and row names for this table, and we can get what we need by using the objective value function on the result. We can also use a get solution function to get the soldiers part of the solution and the trains part of the solution. And so I believe it defaults to returning your variables in alphabetic order, or maybe the order that they're defined. Not 100% sure, but this is a good way of sort of choosing what order you're receiving your results back in. And so especially if you wanted to reorder your solution output, you can use the get solution to grab specific parts of the solution and assemble them into a table. So in this example, I broke everything down into separate steps, but in practice, you can do this all in one step. And I'll show you sort of how I do it step by step as I'm coding it up. But yeah, this from start to end would create the model, add the variables, set the objective, add the constraints, and solve the model all in one code chunk. And so you can just continually pipe the output of one step into the next. And so if I were coding this from scratch, I wouldn't try to write the whole chunk of code in one go, but rather I would start at the first line, pass it into, and then write the second line, check what I'm getting at that step. And each step along the way, I'd add one more line of code and check what I'm getting, add one more line of code, check what I'm getting. So that is essentially an example of the Geppetto problem, how to solve it in R. So